Hey guys, welcome to Datasie. In this video, I want to go over the concept of the limit of rational functions at infinity. In the first example, we have the limit of 2 times x squared minus x plus 3 over 3 times x squared plus 5 as x approaches to infinity. In the sum 1, we need to find the largest power of our rational functions, which is x squared. So we need to divide the numerator and denominator by x squared. The limit of 2 times x squared minus x plus 3 over x squared, and in the denominator we have 3 times x squared plus 5 over x squared as x approaches to infinity. We need to simplify numerator and denominator. 2 times x squared over x squared is equal to 2 minus x over x squared is equal to 1 over x and plus 3 times x squared. And the denominator we have 3 times x squared over x squared plus 5 over x squared. And after simplification, we have 2 minus 1 over x plus 3 over x squared over 3 plus 5 over x squared. And in the step 2, we need to substitute infinity into the expression. So we have the limit of 2 minus 1 over infinity plus 3 over infinity squared is equal to infinity. And in the denominator, we have 3 plus 5 over infinity squared, which is equal to infinity. So we have the limit of 2 minus 1 over infinity is equal to 0 plus 3 over infinity is equal to 0 over 3 plus 5 over infinity, which is equal to 0. So the final answer is equal to 2 over 3. In the second example, we have the limit of x to the third power plus 3 over x squared plus 2 as x approaches to infinity. What is the limit of this rational function? In the first step, we need to find the largest power of a rational function, which is x to the third power. So we need to divide the numerator and denominator by x to the third power. So we have the limit of x to the third power plus 3 over x to the third power. And in the denominator, we have x squared plus 2 over x to the third power as x approaches to infinity. So, by simplifying numerator and denominator, x to the third power over x to the third power plus 3 over x to the third power 3 over x to the third power over x squared over x to the third power plus 2 over x to the third power. In step 2, we need to substitute infinity into the expression. So we have 1 plus 3 over infinity to the third power over 1 over x plus, or which is 1 over infinity, we can say 1 over infinity plus 2 over infinity to the third power, which is equal to infinity. So the limit of this expression is equal to 1 plus 3 over infinity, which is equal to 0, and 1 over infinity, which is equal to 0, plus 2 over infinity, which is equal to 0. And the final answer is equal to the limit of one plus 0, which is equal to 1, over 0 plus 0 is equal to 0. 1 over 0 is equal to infinity. And the last example, we have the limit of x plus 4 over x squared minus 9 as x approaches to infinity. What is the limit of this function? The degree of numerator is less than the degree of denominator. So, the largest power of this rational function is equal to x squared. And like the previous example, we need to divide the numerator and denominator by x squared. So we have the limit of x plus 4 over x squared over x squared minus 9 over x squared as x approaches to infinity. We need to simplify the numerator and denominator. So in the numerator we have x over x squared, which is equal to 1 over x plus 4 over x squared over x squared over x squared is equal to 1 minus 9 over x squared. X over x squared is equal to 1 over x plus 4 over x squared is equal to 4 over x squared and 1 minus 9 over x squared. And in step 2, we need to substitute infinity into the expression. So we have the limit of 1 over infinity plus 4 over infinity squared, which is equal to infinity, over 1 minus 9 over infinity squared, which is equal to infinity. So we need to calculate the numerator. 1 over infinity is equal to 0 plus 4 over infinity is equal to 0. In the denominator, we have 1 minus 9 over infinity, which is equal to 0. So the final answer is 0 over 1 minus 0 is equal to 1, which is equal to 0. If you have any question, feel free to ask them in the comments. Thank you for watching and make sure to subscribe to my channel for more tutorials.